Let's do it. So today I'm going to start with Friday slides, and then we'll go back to Wednesdays and do as much of Wednesdays as we can. Probably be able to get through it all if I go to a healthy pace. So we have one last objective for homework 2, cross-site request forgery tokens. So we're going to talk about this today. For this objective, the design of this is largely up to you, as long as you're generating random tokens and attaching them the way we're going to see in class. Reminder, I do have the lecture Discord. If you have questions, either post them there or just old-fashioned raise your hand. This is the last day of homework 2 content. Then Monday we'll start WebSockets. So let's do it. Oops. Cross-site request forgery. So this is an attack. This is an attack that we need to be very aware of that could open a huge security hole in our site. So let's talk about what this is first. Cross-site request forgery, often abbreviated XSRF. Whenever you see an X in these web abbreviations, it usually stands for cross. Use X's instead of C's. Don't ask me why. It's just cute, I guess. So cross-site request forgeries. This is where JavaScript from one page is going to make a request for a malicious request for another site. So you're on one server, got some JavaScript, and you make a call to another site, an attack site. When it's cross-site request forgery, the forgery part means it's for malicious intent. There are common intents, peaceful things, reasons to be able to do that, but the request forgery is when we're doing that to attack. So for example, you get an email, very suspicious link, and they're like, click this link for your Microsoft account has been compromised. Click here to change your password or whatever. Some silly, we've all seen the spam emails, some silly email with a really shady link. You click on that link, you go to this attack site, and that site has some JavaScript running on that on the site. You download that JavaScript onto your machine and run it as your own, like how websites are meant to work. You run that JavaScript as your own, and that JavaScript contains an ajax request. I guess that doesn't make sense since we skipped the ajax on Wednesday, but we'll talk about ajax at the end here. Makes an ajax request, which is an asynchronous JavaScript request. It means making a request to the server after the page loads is the TLDR of it. So make a request to Autolab and either gets your grades, makes submissions on your behalf. Maybe it makes a forged submission, something that somebody else submitted, so you get caught for AI. Silly things like that. Somebody could attack you with. So this malicious site has JavaScript that sends AJAX requests to Autolab, or worst case, you fail a class and you retake it next semester, or it goes to your bank account, which not to undermine that, but or it goes to your bank account and starts moving money. Now, maybe depending on your priorities, maybe a little more severe. If it starts bleeding out your bank account, maybe it takes the maximum cash advance on your credit card and dumps it into their account. It can do silly things like that that can jam you up for years and lose you a lot of money. So this is what we want to avoid. This is a cross-site request forgery attack. We would like to avoid this at all costs. We don't want JavaScript from one site being able to send requests to another site if those requests are sensitive. To prevent these, we actually have a really good layer of protection called CORS. This is a policy enforced by the browser, which is going to block most cross-origin requests. So when one site has JavaScript that makes a request to another site or another host, another different domain name, a different IP address, a different host in general, that's what we call a cross-site or a cross-origin, a cross-site request. So the cross-origin request sharing policy is going to say, for most of those, we're just going to block them. So the browser just says, let's not allow that. For most requests by default, especially post requests, we're going to block those by default. So this is really good. It's depending on your outlook. This is good. The browser is going to help us. Most modern browsers are going to help us really clamp down on this. Now some requests are going to be sent. There are things where we can allow CORS, and there is a header we can set to allow CORS, allow cross-origin requests. For example, if you have an embedded image in your site and you use the full URL, you're not hosting that image on your server, you might give the full path in your image tag. That's going to require a CrossOrigin request. You import Bootstrap into your project, and you don't download the Bootstrap library and host it on your server. That's going to be another CrossOrigin request. So there are legitimate reasons for this. We can't just say no CrossOrigin requests ever. That's way too restrictive. We can't be that strict about it because there's examples where we're going to want to do that. Yeah. Why is the acronym not XORS? It's a good question. I don't know. Probably because CORS is easy to say, is my guess. Whoever came up with the acronym is like, well, we could just say CORS instead of XORS. I don't know. I never really thought about that, but that's a good point. XORS. So when we do want to allow these, we can set this header like a CDN, like hosting all the JavaScript libraries, so a CDN that's hosting Bootstrap or jQuery. They're going to say, yeah, allow anybody to grab this stuff. That's the whole purpose of that server, is to host those libraries to be able to be imported into websites. So they're going to set this header and say, look, let everybody get this. I don't care what origin it is. It doesn't have to be the origin of this CDN. Let everybody grab these libraries. So we can set these. If you've built websites before and you got into a jam, sometimes the solution is to set this where you just allow all requests. It's usually a bad solution, but if you have like two different servers, say you have a front end and an API or something that are on different hosts, and you need them to communicate to each other, this will let them communicate to each other, but it also lets everybody communicate. It effectively removes CORS protection. It tells the browser, hey, look, I know what I'm doing. Everybody can access this. Don't worry, I'm secure. Don't worry about it. So if you do set this header, everybody can have cross-origin requests to that site. So it's something to be aware of. If you ever, Stack Overflow says, oh yeah, just allow any origin. Just remove CORS. Just be aware of that. This is what you're doing. You're allowing these attacks. So if it is a sensitive path on your site, just make sure you're thinking about the implications of this. So CORS is enforced by the browser. So we don't have control over this. This is just something that exists out there in the world of web development. The browsers implement CORS, and we get what we get. So this isn't completely foolproof, because what if a user's using Internet Explorer 6 still or something, so like that. They're still running Windows 98. There are still people out there like this, and it's nothing wrong that they're doing. It's maybe they just can't afford an upgrade. But there are people with very, very outdated browsers out there that were built before CORS existed, before we really knew the implications of security in the internet, before we knew that people were going to use the internet for so many malicious things. There were browsers written back then. We got to protect against that. There are a lot of plugins that people like to have that'll make their web experience better. We all probably have at least a few of these. But if you're shopping in the real shady, plugins or development plugins, I've seen students who were building their apps and CORS kept getting in the way, so they downloaded a plugin in their browser that disabled CORS. Like explicitly, like that was their goal, is to find an extension that disabled CORS, which probably made their development a little easier until they try to use that anywhere else outside of a browser that has that extension, and then everything breaks. But also, that user is, fine for development, I guess. They go out there on the internet, well, they don't have CORS protection anymore. They're vulnerable to these scripts. And there are some kind of obscure browsers. People like to get cute with their browsers sometimes. I venture to Opera. I won't go farther than that, but some people go farther and find some more, not that Opera is really obscure, but people go out there and find more and more obscure browsers, which maybe they implement CORS correctly, maybe they have all the protocols correctly coded and doing everything they're supposed to, but are you verifying that? Like, we can verify that not verify, but we can be reasonably confident Chrome is implementing CORS correctly, because if they didn't, it would make the news. Like, so many people would be vulnerable, so many people would be immediately attacked. If some small browser with a few thousand users isn't implementing CORS correctly, we might not find out about that. Like, how do you get that assurance that they're doing the right thing? If they're open source, you could paw through their source code. Like, do you really want to do that, though, just to get a browser? So CORS isn't 100%. It's really good. It's a fantastic addition to the internet, if that's the right word, but it's not 100%. So let's talk about what we can do. And what Objective 5 on homework is cross-site request forgery tokens, XSRF tokens. So let's have a server-side approach that's going to work regardless. Even that user with Windows 98 and Internet Explorer 6, we're still going to be protected for that user. Or somebody who, as a hobby, wrote their own browser. Maybe that's the thing, which would be fun. Let's have a server-side solution that's going to work regardless of the client. That's something that we can control. So here's XRF in a nutshell, XSRF in a nutshell. On the server, whenever we get a page load, we get a request for our page, any page with a form on it, we're going to generate a random token. We're going to embed that token somewhere in the page. We're going to get that token to the user one way or another. We're going to embed it in forms is the way I'll show you. But for your homework, I forget exactly my wording on it. My intent is that you embed it in a form, but I may have worded it loose enough that you can use a different solution if you want. But we're going to give them, the form is the easiest one, by the way. You should just do that, unless you want to get really fancy. Generate the token, embed it on the page, send it to the user, and then when the user submits that form, make sure that token was submitted with the form. Now, for anybody who makes a request, who submits that form, or makes a post request with the data that we expect from that form, it doesn't, remember, the front end is a complete illusion. It doesn't have to be made through that form. It could be made from JavaScript, from another site, from some attack site who wants to attack us. Everybody who visits that site might run the JavaScript and simulate a post request, send a post request that's the same exact format as the form would send. So we don't know that the form was submitted, but we know we got a post request for a specific path from somewhere. It could be from Postman, could be from an attack site, could actually be from our form, could be from our form, but somebody who edited all the HTML. We just don't know. All we know is we got a post request that looks like it came from our form. So with the cross-site request forgery token, we're going to get that request, and we're going to check for that token. If that token isn't there, deny the request, send them a forbidden, send them, hey, you did something wrong, you're not allowed to do this. If we find that token, treat the request as normal. If these tokens are long enough and random enough, nobody's going to be able to just randomly guess a token. So we want nice random tokens. For those of you, before you ask, you can use the secrets library in Python for this, or I forget what people used in Node and other languages. But if you want to pull in a library to generate the tokens for you, that is allowed on the homework. So that is a library I'll allow you to pull in. If not, write a method that generates random strings and use those as your tokens. And those strings should be hard to guess. I'm going to be fairly loose with that definition. I'm not going to have you measuring entropy and stuff like that. But if you're using like sequential numbers, my tokens are 1, then the next user has the token 2, then 3. That's not going to get you any points. That'll get you a 1 on the objective. They should be reasonably random-ish. I'll leave it loose like that. There has to be an effort for you to generate big random tokens. Ideally, a method that takes in an int and returns a token of that length. If you have a method like that, or a function like that, depending on your architecture, I'd be fine with that. So this is the structure. This is, if you're looking for one slide that has Objective 5 on it, this is the high level, this is Objective 5. Yeah, mercenary, those tokens would not be, it shouldn't be, so the user shouldn't be able to identify a pattern in general. So an attacker trying to guess these tokens, they can legitimately go to your site. They can go to your site and keep re-rolling tokens. They can keep hitting refresh and checking the token. If they sense a pattern, they're going to start being able to guess those tokens and guess what token you gave a particular user. And once they can guess that, now their attack site can be effective. We don't want that. We're not going to get 100% security with this method. What we would like to do, what we would do in the future, is tie these tokens to a specific user and then make sure that we got a request from this user with this token. Then we get full security. But we don't have authentication in user accounts yet. That's not the homework for, so we can't quite go the full mile with this. But we're going to get the idea of what this does. And this is a reasonable layer of security. But in your homework, if you check if the request has any of the tokens that you've issued, then accept it. It's going to be okay. Technically, it does open up an attack because the attacker can go get a token and then send that token in their attacks. But we're going to be okay with that for the homework because we're testing the concept. We're getting you understanding the concept of these cross-site request forgeries. Once you say, okay, I got a request from this user, go to your data, generate the token, go to your database, say this token is for this user, attach that token to their request. Now there's no getting around that. The attacker would have to get a token for that user. It's just not going to work. Then when you get the token, you check, who's this token for? Hey, this token isn't for you. I gave this token to that attacker over there. You can't use this token. It's not legit. And then you deny the request. And my strong recommendation is to embed this right in the form. With what you know now, it's hard to do anything else, I guess. Until we talk about Wednesday slides, I suppose there's another option there. But right in the form, add a hidden field. So in your HTML template, add another input where this is a placeholder. You're going to inject your token or render your token, and then put hidden on the field. Hidden is going to not display that to the user. The user can still check the HTML and still see that token. It's not private. But it's hidden just for usability. You don't want this to be exposed to a typical user because they're going to be like, what the hell is this random stuff? It's just going to confuse them. They're going to get worried. People see stuff they don't recognize, don't understand, they panic. So we just hide the field so the users can't see that. And then since it is another input with a name, when this is submitted, we're going to have another part of our multi-part form with that token in it. Parse that token, just like you're parsing your other parts, and then check if that is a valid token. If it is, honor the request. If it's not, don't. So for testing, we'll go into your site, modify that token, submit the form, and we should get a forbidden response of 403. Any questions? Everyone good on what Objective 5 is asking you to do? All right, let's go back to Wednesday slides and see if we can, we're not going to get through all these, are we? If I have time next week, I might go through all of them. This is, again, like I said last time at the end of lecture, this whole slide deck, this is stuff that I'm not really requiring you to do. There are some points in the semester where it'll help to know how to write AJAX requests. Honestly, if you made it here, you probably wrote AJAX requests before. I think it's a fairly safe assumption, but anyway, we're going to go over it at one point or another, even if we don't get through everything today. But most of this is nice to know. This is stuff that you need to know if you're going out there in the world of web development. Polling is one of the topics we'll talk about today. If you go out there for a job interview and they're like, what's polling? And you're like, I don't know. You might not get that job. So I just want you to be familiar with these terms for the most part. And then instead of using these approaches, we're going to use WebSockets in the next homework. So what we want is user interaction. I showed you that chat site, the one that I was using to show you escaping your HTML and sanitizing your HTML so nobody can inject JavaScript. So we have a chat site, we have interaction between users, but it's slow. If you notice that site, I would click send, it would take a little bit, and then the message would pop up. That's fine for chat. I mean, if you have a second or two delay on chat, you might not even notice. It might get annoying at some point if you're having a really fast conversation with somebody, but you might not notice that well. But what if you have something where you really need live interactions? What if you're playing a game and two characters are moving around and they're just super laggy? It's not going to work for us. It's just not what we want. Or what if you do just want really responsive chat? We're going to need something faster. So right now, all we know is sending a request to the server and the server responds. So what we can do with that, actually I did the wrong setup here, didn't I? We're still at page reloads. So right now, the user has to reload the page. So how did I do that in the chat app? That was the setup I was supposed to do. Right now, the user has to reload the page. All we know is I get a request, I respond, I can respond with HTML, and the browser's going to render that HTML. So how do we load content after the page loads? And then we'll talk about getting it faster. So after the page loads, we're going to use ajax requests, asynchronous JavaScript and XML. The and XML, we don't really use XML for like anything on the web anymore, but the acronym stuck, the AX on the end stuck, so we don't just call it AJ, it's Ajax, because it's just what we've been calling it, and we're not going to change an acronym for whatever reason. Nobody wants to change it. I mean, I don't care either. So we're going to make JavaScript or HTTP requests via JavaScript after the page loads, and it looks like this. So this is an example of an AJAX request. Most of you, like I said, most of you have probably seen this before at one time or another. We do it in 199 in Alan Hunt's module. So if you took that, you've at least seen this, but maybe you didn't understand. You probably just pasted it into your code and said, we're good. Actually, does he do AJAX? It doesn't matter. So this is what an AJAX request looks like in pure JavaScript without jQuery. For those of you who like using jQuery, the syntax is obviously a little different, but it's the same concept. We're going to create a new XML HTTP request. Again, XML we moved beyond that, but the name stuck. So we're going to create an XML HTTP request. This is our AJAX request object. And then we're going to populate the fields of this object and access its behavior to be able to get this AJAX request sent. So the request, we're going to set the request type and the request path in JavaScript. And when we call .send, it's going to fire that request off. So right there in those 3 lines, that's how we can send an HTTP request to the server after the page loads without reloading the page. So if we want an app that loads and then we have live interactions and communication with the server, this is how we want to do it, AJAX requests. Everything in the middle here, this is what we do after we get the response from the request. So normally you would send a request, the response would be HTML, and then you would render all the HTML. With AJAX, that's not, and then there might be other requests for like images and JavaScript and CSS and stuff. With AJAX, that's not usually the case. We're going to get some data from the server, and we're going to process that data. So with this, we're going to set the onReadyStateChange field. This is going to be set to a function that's going to be called whenever the state of the request changes. When that state changes to ready state of 4 and a status of 200, ready state 4 means that we downloaded all of the data, we're not buffering anymore, we got all of the information of the request, or of the response. And 200 means we got a 200 response code. Status is the response code. 200, we got a 200 OK. That means everything went well. We're ready to process this thing. And then we have this the response variable, the response field. That's going to contain the body of the response that we got from the server. So this is all the data that we were concerned about. And then I'm just logging it to the console. But this is where we would do whatever we want to do with that information. So if we're making a request for like get chat history, this is where we would render the chat history to our HTML to the page. We would look for a div where we're putting all that information and then render some HTML to display it to the user. If we want to send a post request, we're going to switch get to post, of course. And then when we call send, we're going to give it an argument, and the argument's going to be the body of the request. And then the browser is going to handle all of the content type, content length, all that good stuff. The browser's going to handle all this. We're just going to give it a string here. Let the browser do its thing. The browser's going to know exactly what to do. Measure length in bytes, handle Unicode, all that good stuff that we do. The browser's going to do all that. We're just going to send whatever we want to send. I'm going to send some JSON. And also process the response. For some post requests, maybe we don't want to process the response. Maybe in the processing the response, we just want to check for error messages and just check if it's confirmed that the server confirmed that they got our message, then we're happy. Whatever we want to do with that. But we can send any data, send any requests, and then handle the response however we want. And that's Ajax. So this will go in your JavaScript, and then you can use any events on the browser to be able to send these Ajax requests, to call your Ajax code or your JavaScript code. So there are a few reasons to do this. By the way, you see this all the time on the internet. You'll click on a page, your page is going to load very quickly and with no content, and then the content slowly starts popping up. This is happening through Ajax requests. We want that first page load to be very quick. We don't want to give users a reason to navigate away from our page. Somebody clicked the link to come to our website, we want to keep them there. So give them something to look at right away. So the HTML loads right away, the CSS loads right away. The JavaScript is downloaded and ran, and that JavaScript is firing off Ajax requests to get the actual data, which might require database lookups, might require algorithms to be able to figure out which content to send this specific user. There might be some heavy processing going on with that. It's going to take a little longer. And just to send all the data might, just might be a lot of bytes. So those happen with Ajax requests, and then that data slowly starts populating as the page loads. And you can see this with most modern sites. Site loads, then the content comes. So you get faster page loads. Faster page loads are very important on the web. If a page takes like a second to load, and it's something that the user doesn't have to use, a site they don't have to visit, they're probably like, I regret clicking that link. Let me go to the next result on my Google search. I know I do that. So this is one big use for Ajax. And instead of having the page reload every time the user wants to do something, this can clutter up the browser history. It can have some negative side effects. If you're reloading the page every time, say, somebody enters something into the chat, if that requires a page reload every time, the page might flash every time they submit. It's just bad for user experience. Uses up their data, sending all the HTML every time. Hopefully it's cached and they don't have to worry too much about it. But a lot of reasons to want to do this. Especially if it's a game, reload the whole game or render the whole thing every single time you update a frame. It's just not going to work. So let's talk about sending a multi-part. So we saw how to send a post request, but how would we send a multi-part form using an Ajax request? If you want to use Ajax requests and still, you already have your multi-part form code, it's all written, or at least it will be by the deadline, and you would like to reuse that code, but you also want to use Ajax, well, you're in luck, there's a way to do that. So with our form, our multi-part form, instead of submitting with a post request to a specific path, we're going to use the onSubmit and call some Ajax, call some JavaScript code that we have, and it's called the send message with form method, which is going to contain my Ajax stuff. And then importantly, I'm going to put return false here. With this return false, this is going to tell the browser, hey, shut everything down after you call my function. Don't fire off a request to the server. If a form fires off a request to the server, the page is going to reload. It's going to reload with whatever the form responds with. If that form isn't responding with HTML, what are we going to reload with? Just some JSON, just some data. So we're going to do return false to shut off the form and just handle the form submission with our function. Now in our JavaScript, we can get the data of the form using some built-in functionality. We're going to create a new form data object with the div of the form, or not the div of the form, the element of the form. So we're going to get that element, create form data, and then just ship it. And the browser will know everything what to do with that. You're going to get a request with your regular multi-part encoding, with your multi-part stuff, your boundaries, the right content type. All that stuff is going to be able to be parsed exactly the way you would if you just sent it with the form like this. So this is handy if you want to do some, one, avoiding the page loads, of course, and two, if you want some more customization. Maybe you want to check the inputs, validate the inputs of the form, not for security reasons, but for user experience reasons. Validate some form inputs before you send it. Do any processing you want to do on the front end. Of course, validation has to also be done on the back end, but if you want some UX validation, you have that option there. But typically, once we're using Ajax, we're going to get away from the multi-part form encoding unless we're sending files. I guess you could. Could send? No, no, you can't. Unless you're sending files. I'll stick with that. If you're sending files, multi-part form encoding. There are ways you could send a file without multi-part form encoding with Ajax requests, with base 64 encoding, and then I don't want to get into all that though. There are ways to do it, but we have the ability to get away from multi-part form encoding or URL encoding. Those are the two ways we know to send information to the server. We can get away from that and start using our best friend JSON in our requests. So let's look at another example. We're going to get rid of the form completely and process our submissions, our form submissions, using JavaScript. So instead of a form, we're just going to have inputs floating around. We're going to give them meaningful IDs so we know how to access them. And then instead of an input of type submit, we're going to have a regular old button. A regular old button that's going to call some JavaScript, which is going to fire off an Ajax request. So now whenever we click this button, we're going to get to send, we're going to call send message. And then send message can get the information we want, put it in an Ajax request, and send it to the server. So we can go to the elements with the inputs, the elements that are inputs that have the data that the user inputted, grab it from each element, do a little manual processing, but this gives us more flexibility, more control, and then send it. And now we can control the format of what we send. Instead of just sticking with URL encoded or multi-part form encoded, or plain text, which you shouldn't use, we have full flexibility. Whatever you can code, that's the format you can use, which in the web we like JSON. So anything we can put in JSON strings, we're going to put in JSON strings. It's, Sean, it is sending another GET request, but the page doesn't auto-populate with it. Well, I guess it depends what you mean by auto-populate. It'll do whatever we want with it. So with this on-ready state change, that's where we're going to put our processing. That'll be called and happen automatically after we write the code, but it'll be with whatever code we write. So the code would be like looking for a div where we're putting our content and then stuffing all that information in there, editing the inner HTML of those elements or however other way you want to get that content on the page. So it's auto-populates to the user, but it's you got to write the code that's going to populate it to tell it where to go. But yeah, once it's all set up, it's going to be automatic. So the user's going to click this button, and the page is going to change with whatever your code does. When that request is sent, response comes back, then the page updates. It's going to do whatever you code it to do. Gives us a lot of flexibility. And any code you put in here, like I like to clear out the chat box, chatbox.value equals empty string. I like to do that so it clears out the, right on the request. So it clears out the box. After it's sent, you don't want that old message sitting there. So you can process when the request is sent, process some more when the response is received, process the response data, any JavaScript code you want to happen whenever you want it to happen. You have a lot of flexibility here. Where with a form, it's really rigid. Forms are really rigid. There's really not a whole lot you can do with them. But they're really nice. If you want the default behavior, forms are really easy to work with, very convenient. We didn't do much on the front end when we were working with forms. But now we get more flexibility, but you also have to write some JavaScript code. So there's some trade-offs. If you just want that default behavior, just use a form. Which brings up a question of rendering content. So when we rendered content, we used HTML templates. And that's the way I showed. I had a whole lecture and we talked about HTML templates. But now with ajax requests, we can bring up this question of when should we render content? We have this option. Well, let me refresh HTML templates, I guess. With HTML templates, you're rendering the template server side, you're using your CPU, your resources, and then sending the completed HTML to the user. This has limitations. What if you want your app to host a mobile app, for example? Your server to host a mobile app. So the alternative, we have another option now, is have our server just serve raw content. Just serve JSON data, just raw data. And then have the client render that into HTML. So your JavaScript code that you send them, not just raw data, but the HTML, very basic HTML, JavaScript, and maybe some CSS. And then all of the real functionality of your server is just serving data as an API. So now when you're just sending data, the client is going to get that data, process it with your JavaScript code that renders HTML, and then they generate their own HTML, get the finished product, and then display that finished product on their front end. So we're going to offload the work to the front end, use the client CPU, get some load off of our servers, so there's a trade-off here. Who should do the work, the client or the server? And just host the API, which makes a lot more things feasible. So maybe that's not the best way to word that. But now, say we want to add a mobile app. You have your server, you put so much work into it, and it's a web server, and you want to slap a mobile app onto your thing, into your ecosystem or whatever. Now you write some app code that's going to render your JSON in whatever format you want for that particular app. And you just connect to the same database, or the same server. Server's just serving up raw data. Everything can consume that raw data. Doesn't matter what it is, a phone app, tablet app, a desktop app, or a browser or a website. It doesn't matter what it is, it can consume JSON, and you can write code for that front end to consume that JSON and render it to the user. This is how apps like Netflix has apps for every device ever. Well, they didn't rewrite all of Netflix code for every one of those devices. They just wrote the front end code for each device that can consume the data from their API. And then the API is set up in a way that all of those front ends can consume that data. And then for each app, you write whatever has to be specific for that app, like the code that controls the layout for that particular app. It's going to be different if it's a desktop app or a web app, whether it's HTML-based or Java-based or whatever it is. It's going to be a little bit different. But then you just write that code to be able to consume that API. One API, one server, and you can host all kinds of apps on all kinds of different platforms. So this is a way we can expand outside of the browser if we want to, if we're set up as an API. Very flexible. All right, so we wanted to make our content live. Somebody sends a chat message, we want everybody to be able to see that message. To do that, we could send an AJAX request, but when do we send an AJAX request? We can send an AJAX request every single time we want the latest chat message, the latest data. And polling is a way to say, well, when? How about just all the time? Polling is sending that request at regular intervals, which we have set interval in JavaScript. We're going to call a function at regular intervals. For this one, I say 1,000 milliseconds or every second. So now every second my get messages function is going to be called. My get messages function sends off an ajax request to get the messages from the server. I handle the response by rendering all of those messages to the page. So this is polling. So this is how we're finally getting interaction between users. So if there's a chat user who's just sitting there and not chatting, we want them to still be able to get the latest chat. We don't want to force them to type something in that fires off an ajax request. You know, that's not very user friendly. So just every second, we're going to fire a request, get the latest chat, render the new messages. So that's polling. But polling is, I guess I'll say it on this slide, but polling has its limitations. One, you're waiting at least at most a full second to get the latest data. For real-time apps where you have real-time interactions between users, that can be prohibitive. Like my example of a game, if every second you see the other players move and just jump around once a second, you're not going to play that game. Depending on what exactly the game is, it's probably going to completely destroy the experience. So we don't want that. And if nobody's doing anything, you're still firing off these requests. I had a DigitalOcean instance where it started blocking requests from UB because I used it as a lecture example. It was a chat app with 1 second polling. And I told the class, hey, go to this site and let's use this as an example. There's so many requests being sent to that DigitalOcean container that it started blocking UB IP addresses and just said, I'm getting DOS attack from UB. I'm going to shut these down. The DOS protection kicked in. And I'm like, oh crap! So it went down during the lecture. I was looking into it, and then I was doing the math. I'm like, well, I think it was 115 with 150 students, and with polling once a second. So every minute, I started doing the math and added up to, I forget. You could do the math, I guess, but it was like 10,000 requests at least just bombarding that server. So their DOS protection kicked in. So it really increases the number of requests in that bandwidth that's being sent. So let's introduce long polling. With long polling, it's similar to polling, except, I don't know, longer. The client is going to send a request, and the server is going to intentionally hang. The server is just going to sit on that request. If it has data to send, if it has any new information to send, it's going to respond to that request and say, here's your new data. If there's no new data to send, the server's just going to sit there. It's just going to let that request sit there and not respond to it. After like 10 or 20 seconds go by, the server's going to respond with, nope, there's no new data. So we're going to have a limitation on how long it's going to hang. It'll hang for some fixed amount of time and then respond and say, nothing new. Whenever the client gets a response from a long poll request, it immediately sends off another long poll request. So if there's no data to be sent, we're going to send a request. 10 to 20 seconds later, we get a response that says no new data. We send another request. 10 to 20 seconds later, no new data. Send another request. Keep sending requests. So what we get, and even if the server has data to send, here's your new data, fire off a brand new request again. So in effect, what we have is the server always having a request open for each client that's connected. Every client has a long pull request just sitting there, and when the server has information, say this user chats, we respond to all the long pull messages. Hey, we got a new message. And then we get all these long pull messages back, long pull requests back. So when the server has information, just immediately respond to all the long pull requests, and then we get new long pull requests coming in. So whenever the server has information to send, you get it immediately. Not immediately, but within network delays. However, how fast that server can send that data to you, how fast your ping time is with that server. That's how fast you're getting the data. You're not waiting that maximum of up to the polling time. Because like with polling, okay, we set 1 second. We want it faster. Let's set that to 1/4 of a second. Well, now we have 4 times the number of requests, and it gets messy. With long polling, we get way fewer requests, assuming there's low traffic, and we're not getting updates every 10 milliseconds or so. But then we could batch them, there are options. We have way less traffic, and we still get user interaction. In fact, we get live interactions here. We get immediate responses. You send a chat message, somebody's getting that effectively immediately, minus network delays. So this is really nice. So we're not going to use long polling. I want to introduce it out there because it's, is it on this slide? It's the next slide. But it's a term you're going to hear out there in the world. We're going to use WebSockets. It's a more modern solution. It has the same end goal of live two-way communication between client and server. But it's, I don't know, I don't know how else to say it other than it's a more modern solution. It's a better solution. Let's say better. But long polling, there are a lot of major sites that still use long polling for various reasons. It's still used out there just because WebSockets exist and there are new protocols coming out that are aiming to replace WebSockets. Just because those exist doesn't mean WebSockets are obsolete. Just because WebSockets exist doesn't mean long polling is obsolete, because a lot of companies still use this stuff, especially major companies that have a lot of legacy code that don't want to update every time a new protocol comes out. Famously, Facebook chat is still using long polling, and they're like, it works. Why would we change it just because some new fancy thing that that our new hires came out of school knowing? They think it's really cool. We're not going to change all of our hundreds of thousands of lines of code, and that's common in the industry. You'll have companies using really old technology because they wrote these huge code bases in this code, and when the new technology comes out, it's usually just the startups that are going to use that new technology, the fanciest, latest thing. It's only the startups that are going to use it because they can afford to. If you have a code base of millions of lines of code, and a new technology comes out, you're not rewriting all that. It's just not going to happen. That's why developers for really old languages that we really don't use anymore, like Fortran, developers with those languages have phenomenal career opportunities, because there are companies out there with really old code bases, really old legacy code that need developers who know that technology. So all that to say, you'll probably see long polling out there in your careers. It still exists. That's why I want to at least mention it here. It's not just, oh, we got better solutions, so we're never going to see that ever again. You're going to see it out there. It exists. It happens. You can go to certain sites. I don't have, besides Facebook chat, I don't have a good one on the top of my head. But there are sites that use long polling. You can look at it in the network tab of the console. You can see these requests. When you see a request that takes like 15 seconds to respond, and then you see another one right away that takes 15 seconds to respond, you know what's going on. You know that's long polling. We got through 2 days of slides. We did it. We'll have to revisit this next week. Any questions on any of this? I got to check chat too. Chat's good. Yes.
This is one about the XSRF, but if you get a request and the token isn't what you expect, would you send over like a 400 level?
Yes. Yeah, I'd send a 403 forbidden. You're not allowed to access this. Anything else? All right, have a great weekend, everyone. See you Monday.